We are going to discuss Lesson 7 in Chapter 1, Constant Rate of Change. Essential question: how can you show that two objects are proportional? Vocabulary, rate of change, and constant rate of change. To the left, vocabulary startup. A rate of change is a rate that describes how one quantity changes in relation to another. In a linear relationship, the rate of change between any two quantities is the same. A linear relationship has a constant rate of change. This is on page 65 in your textbook. Real World Link. A computer programmer charges customers per line of code written. Fill in the blanks with the amount of change between consecutive numbers. The top portion is lines of code. It goes from 50 to 100 to 150 to 200. So each time we are increasing by 50. Next, we have the cost in dollars. Goes from 1,000 to 2,000, 3,000, 4,000. So each time we are adding 1,000. Label the diagram below with the terms change in lines, change in dollars, and constant rate of change. So the $1,000 is the change in dollars. I got this by looking at my information up here, and the cost is the one that is $1,000. Then for the denominator, the 50 lines, that's going to be change in lines. In the next part, the constant rate of change is $20 per line of programming code. We got that by simplifying 1,000 divided by 50 lines, which reduces down to $20 per one line. We reduced it down to the unit rate. Let's use a table. You can use a table to find a constant rate of change. So an example, the table shows the amount of money a booster club makes washing cars for a fundraiser. Use the information to find the constant rate of change in dollars per car. So cars washed, the number goes from 5 to 10 to 15 to 20. So each time they are increasing by 5. Then for the money in dollars, it is going from 20 to 40, which is increasing by 40. From 40 to 120, which is increasing by 40. And from 120 to 160, which is again increasing by 40. We're going to find the unit rate to determine the constant rate of change. In the numerator is the change in money, which is $40. They got that by taking 80 minus 40, which equals 40. Or they could have taken 120 minus 80, which equals 40. 160 minus 120 is also 40. Then the denominator is the change in cars. They got that as 5 cars. So because I took the information of 80 and 40, I want to find the corresponding values in the number, which is 10 and 5. So I'm going to take 10 minus 5, which simplifies to 5. They then took this ratio and simplified it to 8 divided by 1. They had that by dividing the numerator and denominator by 5. So that means $8 per one car. So the number of dollars earned increases by $8 for every car washed. As a reminder, to the left, we have a unit rate. It is a rate of change is usually expressed as a unit rate. So again, rate of change is usually referring to the unit rate. Got it? We're going to do these problems to find out. Letter A. The table shows the number of miles a plane traveled while in flight. Use the information to find the approximate constant rate of change in miles per minute. That means that we're going to take the distance over the time. That means that we're going to take the change in distance and divide it by the change in time. So the change in distance is referring to, these values down here in miles. So I'm going to choose two values. I'm going to go with the first two. And I'm going to take 580 minus 290. So that's my change in distance. Then I'm going to find my change in time, which is the 30 and the 60. I do want to make sure I write it in the same order as my distance, meaning 580 corresponds to 60. So I'm going to put the 60. And then subtract it from 30. Now I'm going to simplify it. 580 minus 290 equals 290. Divided by 60 minus 30, which is 30. This can be reduced down further. I know I can take a 10 out of 29 and out of 30. So that leaves me with 29 divided by 3. When I take 29 divided by 3, that gives me 9.6 repeating, or approximately 10. So the approximate constant rate of change in miles per minute is about 10 miles per minute. Let's try letter B. Whoops. The table shows the number of students that buses can transport. Use the table to find the constant rate of change in students per school bus. So I'm going to set this up for change in students divided by change in buses. Just like before, I'm going to choose my two values in my table for the number of students. And I'm going to take that 216 minus 144. And I'm going to divide it by the number of buses, which I'm picking my corresponding values to my number of students. And I'm going to subtract them in that same order. If I did 216 minus 144, I need to do 3 minus 2. So 260 216 minus 144 equals 72. Divided by 3 minus 2 is 1. That can be reduced down to 72. So the constant rate of change in students per school bus is 72 students per school bus. So using a graph. You can also use a graph to find a constant rate of change and to analyze points on the graph. So examples. Number 2. The graph represents the distance traveled while driving on a highway. Find the constant rate of change. So, for this problem, to find the rate of change, pick any 2 points on the line, such as 0, 0, and 160. There are 2 other points that you could have chosen from, but for this example, we're going to go with 0, 0, and 160. We're going to find the change in miles, which are our y values. In this case, that's our 60 and our 0. And we're going to do 60 minus 0. Then we're going to go in and find the change in hours, which is our 1 and our 0. We want to subtract in the same order we did for our change in miles. So that's 1 minus 0. Simplifying that, 60 minus 0 is 60. 1 minus 0 is 1. So that means 60 miles per 1 hour. Number 3, explain what the points 0, 0 and 160 represent. Zero, 0 represents 0 hours spent traveling 0 miles. 160 represents 60 miles in 1 hour. Notice that this is the constant rate of change. Got it? Let's try this problem to find out. Letter C. Use a graph to find the constant rate of change in miles per hour while driving in the city. Like the previous problem, I want to pick 2 points that are on the number line. That are on the line, not the number line. So I'm going to pick the points 0, 0 and 130. Again, you have 2 other points that you could pick from, and it's completely up to you. So this is change in miles divided by the change in hours. So the change in miles is referring to the 30 and the 60. So 60 minus 30 divided by, now we have to find the change Now we have to find the change in hours, which is referring to the 2 and the 1. I have to subtract in the same order as I previously did. If I subtracted 60 minus 30 for the change in hours, I have to do 2 minus 1. 60 minus 30 is 30. Divided by 2 minus 1 is 1. 30 divided by 1 simplified down to 30. So the constant rate of change is 30 miles per hour. Letter D on the lines below, explain what the points 0, 0 and 130 represent. 0, 0 represents 0 hours spent to travel spent traveling 0 miles. 130 represents traveling 30 miles in 1 hour. Example 4. The table and graph below show the hourly charge to rent a bicycle at 2 different stores. Which store charges more per bicycle, and explain? So we need to find the rate of change. The table shows pedal rentals. Each hour we are increasing by 1. Then the cost increases each time by 12. So for this this rate of change, we could take 36 minus 24 and divide it by the corresponding to hours of 3 minus 2. 36 minus 24 is 12. Divided by 3 minus 2 is 1. So this is saying that it is $12 per hour to rent. So now let's find out for supercycles. We have the ordered pair 0, 0 and 1, 8. So 0, 0 and 1, 8. I'm going to take 8 minus 1. My apologies. 8 minus 0 over 1 minus 0. So I want to take 8 minus 0 and then 1 minus 0. That simplifies to 8 divided by 1, or 8. So Supercycles charges $8 per hour to rent. So Pedals Rentals charges more per hour to rent a bicycle. Okay, now you're going to go and do some practice on your own.